Alright, how's everybody doing out there today in calculus land? We're going to take a look at our integration technique called partial fractions, otherwise known as partial fraction decomposition. We're going to use this technique anytime we've got to integrate rational functions. Now in this example, we've got to evaluate this rational function. Oh, it's so ugly. X plus 3 over 2x squared minus 9x minus 5 dx. So when we go to integrate this, we don't have a technique to integrate it. So what we're going to have to do is break it down into its most basic parts. We're going to have to decompose this into smaller pieces so that we can integrate it. Now, anytime we've got to use this technique, what we're going to do is look to factor. Now, the denominator, 2x squared minus 9x minus 5, that will factor. So that's going to factor into 2x minus 1, or 2x plus 1, and the other factor is going to be then x minus 5. So that's going to be what our denominator will factor into. So it's x plus 3 in the numerator, and when we take a look at factoring this, so to get the x plus 3, we're going to have to add up two other fractions. And then for the denominators, one of them is going to be 2x plus 1, and the other one is going to be x minus 5. So those are going to be our two denominators. Now, of course, we're going to have two constants here in the numerator because the degrees of the denominator are both linear. So we're going to have a constant 1 degree less in the numerator for each one of these. Now to figure out the values of a and b, all right, we're going to simply eliminate the denominators. Now to do that, that means you're going to multiply everything through by the 2x plus 1 over x minus 5. So when we do that, we'll just be left with x plus 3 on the left. And on the right-hand side, a will be multiplied by basically the other fraction, the other piece of the denominator. So a times x minus 5, and then the b term is going to be multiplied by the other denominator, which is 2x plus 1. So that's what we're going to have once we clear that fraction out and we get rid of the denominator. Solving for a and b is just a matter of simply substituting. We want to take each one of these pieces, and like here, we want to figure out what makes that 0. When we do that, we'll figure out the constant for b. And then similarly, when we go to find the constant for b, when we let this piece right here be 0, we're going to end up with finding out what that value for a is. So first, let's go ahead and get rid of the a term. All right. So x minus 5, what makes that 0? Well, if we let x equal 5, then that's going to help us find the b term. So we're going to do this one first. So if we put 5 in, we're going to have 5 plus 3, and then a times then 5 minus 5. And then b is going to be 2 times 5 is 10 plus 1 is 11. So we're going to end up with 8. The a term is gone now, and we're just going to have 11b. And of course, solving that for b is very simple. You get 8/11ths for the value of b. Now to find the value of a, we're going to take a look at this second piece right here of this. B times the quantity 2x plus 1. So to make this term be 0 and cancel out, we're going to have to let 2x, so I'm going to kind of do this on the side, 2x plus 1 to make that be 0. Of course, we're going to end up with x equals negative 1/2. So for the second piece, we're going to let x be negative 1/2, and that's going to allow us to find the value of a. So once we know that we want x to be negative 1/2, we're simply going to substitute that in anywhere there is an x. And on the left-hand side, we're going to get 5/2. And on the right-hand side, we're going to get negative 11 over 2a when we combine all of that. Then, of course, when you multiply both sides by the reciprocal of that, negative 2 over 11 times negative 2 over 11, the right-hand side, those are going to be gone. But on the left-hand side, the 2's are going to cancel out real nicely. So you're just going to be left with a value of negative 5 over 11 for a. Once we have those two constants, a and b, now we're actually going to be able to rewrite. We're going to substitute those in for the a and b values right here. So we're going to go ahead and rewrite this integral now just using the constants that we found, 8/11ths and negative 5/11ths. But this is how we're going to write it. Now, the reason that we're keeping our constants, since they are fractions, we're keeping them on the outside is because we're going to use integration techniques involving natural log, because that's pretty straightforward and easy to do for you guys at this point in your calculus lives. So Ooh, that went a little bit too fast. Here we go. All right, so now that we've broken this down into this piece, when we've got to integrate negative 5 over 11, 1 over 2x plus 1, so we're going to have negative 5 over 11. So we're going to keep that constant just like that. But then we're going to, when we integrate the 1 over 2x plus 1, we're going to have the natural log of the absolute value of 2x plus 1. All right, then of course, because we've got to apply the chain rule, the derivative of what's inside, the 2x plus 1, is just 2. But since we're integrating, we have to remember to do the opposite operation of multiplying by 2. We've got to multiply by 1/2. So all of that is going to be the integral for that first term, and then plus we've got our 8/11ths, and then we're going to have the natural log of the absolute value of x minus 5. Now when we apply the chain rule here for the absolute value of x minus 5, the derivative of x is just 1, and the reciprocal of 1 is still 1. So that's not really going to impact that too much. So from here, we're just cleaning everything up, but do not forget the plus c. All right, very, very important piece there. So clean everything up, and then we're going to have negative 5 over 22, natural log of the absolute value 2x plus 1 plus 8 over 11 times the quantity natural log of absolute value x minus 5 plus c. Now, because both of these are natural logs, this is where things are going to get crazy. All right, check it out. Because a lot of times you might be happy to leave it there, but no, your book may not be happy. So we're going to rewrite this and combine it because they both have natural logs. So we're going to try and combine this so that it's only one natural log. So we're going to use our powers of algebra and arithmetic to do that. So negative 5 over 22 natural log of 2x plus 1, the absolute value of that, plus, now watch what we're going to do here. We're going to get 16 over 22. What? That's crazy. Why did we do that? Ooh, you'll see here in a minute. So we have natural log absolute value of x minus 5 plus c. But notice our denominators are both the same. So we're gonna do some of these crazy things. Check this out. We're gonna rewrite this so that we can have 1 over 22 here. Natural log. Now, if we're gonna have 1 over 22 out in the front, that means this numerator piece, that's going to go to the exponent over here. So we're going to have natural log absolute value of 2x plus 1 to negative 5 power. What? And then the same idea here, the 16 is going to become the exponent of the next piece. So we're going to have 1 over 22 times natural log of the absolute value of x minus 5 to the 16th power, and then plus our c. Now both of these have a common factor of 1 over 22. So let's take that guy out. So we're going to have 1 over 22. Now our powers of absolute value. Let's pay attention to a couple things here because we're going to have natural log. Now in the numerator, we're going to have x minus 5 to the 16th power. Now because that's an even degree, that is always going to be positive. But the 2x plus 1, since that's to the 5th power, we're going to have to make sure we put absolute value bars around that because that's going to be to the 5th power. And anytime you have something to the 5th power, that of course is odd. So in order to not break the rules of natural log, keep everything positive, greater than 0, we're going to have to put absolute value bars around that. So that condenses down to that lovely little fraction. And do not forget, of course, the plus c. Whoa. Oh my gosh, that's a lot of arithmetic and a lot of algebra. But all of this just basically comes about because we don't have a technique to integrate our original function of x plus 3 over 2x squared minus 9x minus 5. So we got to break it down into smaller pieces, which you'll notice we end up using some natural log properties to combine everything and break it down. So that integral just ends up being all of that mess there that's at the bottom. Thanks for watching this video. Appreciate your guys' patience and understanding and working through this one because I know it's a long one, but you got it. No big deal. Just make sure you remember some of your algebra and logarithm properties. Catch you guys later. Have a great day. Peace out.